In previous videos, we've looked at how to calculate the area of the sector of a circle, how to calculate the area of the segment of a circle, and how to calculate the length of an arc. Now, this video is like a special type of sector of a circle. Now, I need to show you something. Now, if I have a circle, and so this is the midpoint of the circle, we've got a radius, we've got another radius. We'll call this place the sector of the circle. Now, in a circle at any given time, we usually have two types of sector. We have what we call the minor sector and the major sector. Now, this is another sector of the circle. Now, remember, in a previous video, I told you that the sector of a circle is 2 radii plus an arc. Now, if you look at this, we've got an arc, and then we've got 2 radii. If you look at this also, we've got an arc, and then we've got 2 radii. So we've got 2 sectors in this circle. Now, this is known as the major sector. Now, this is known as the major sector. The major sector. Why this is known as the minor sector. The minor sector. Now, by just looking, you know that this angle here is definitely smaller than this angle here. And so we've got the major sector, and then we've got the minor sector. I hope you understand this. Now, let's take an example. So we have calculate the area of I minor sector, II, major sector, take pi equals to 22/7. Now remember, this is the minor sector, and this is the major sector. Do you understand that? So let's solve this. So we've got solution. If I'm to draw the minor sector to be something like this, we've got 30 degrees, and then we've got 21 meters. So let's calculate the area of the minor sector. So we have I, area of minor sector. Can you remember the formula for area of a sector? Remember, it's just a fraction of the area of a circle. So we have theta over 360 times area of a circle is pi r square. Now, what were we given? We know theta equals to 30 degrees. We know our radius equals to 21 meters. And then we're given pi equals to 22/7. Now, all we have to do is to slot this into the formula. Area of minor sector, I'm just going to put sector, equals to 30 over 360 times 22/7 times radius is 21, so we have 21 square. Does that make sense? 0 cancels 0, 3 here 1, 3 in 3 is 1, 3 in 6 is 2, 2 in 12 is 6, 2 in 22 is 11. So I'm left with, let me do it somewhere on top. So we have area equals to, I've got 1/6 times 11/7. 21 squared is 21 times 21. So we have 7 here 1, 7 here 3, 3 here 1, 3 here 2. So we are left with 11 times 21 divided by 2. So area should be equals to 11 times 21 should give me 231 all over 2. So I'm having area equals to 2 in 2 is 1, 2 in 3 is 1, remainder 1, 2 in 11 is 5, remainder 1. I put points here, add 0, 2 in 10 is 5. So I have 115.5 meters square, and here is the area of the minor sector. Now that we are done with the area of the minor sector, let's find the area of the major sector. Now, the first thing we need to know is this angle here. We need to know this angle here. Now remember, angle at a point sums up to 360 degrees. So if I know 30 degrees, it means that this angle here will be 360 minus 30. And 360 minus 30 should give me 330 degrees. So it means theta in this case is 330 degrees. Do you understand? So remember, the formula is still the same. Area of major sector, II, equals to theta over 360 times pi r square. Now in this case, our theta is 330 degrees. Our pi is still 22 over 7. And our radius is still 21 meters. So we slot this into the formula. Area equals to 330 over 360 times 22 over 7 times 21 square. Does this make sense? 0 cancels 0. 3 in 33 is 11. 3 in 36 is 12. 2 here 6. 2 here 11. Now let's do the remaining somewhere here. Alright, so we have area equals to 11 over 6 times 11 over 7 times 21 square is 21 times 21. 7 here 1, 7 in 21 is 3, 3 here 1, 3 in 6 is 2. So we have 11 times 11 times 21 divided by 2. So area equals to 11 times 11 will give us 121. So we have 121 times 21 all over 2. So area equals to 121 times 21 should give us 2541 all over 2. So area equals to 2 in 2 is 1, 2 in 5 is 2, remainder 1, 2 in 14 is 7, 2 in 1 is 0, remainder 1, 2 in 10 is 5. So we have 1270.5 meters square. And here's the area of the major sector. I hope you understand this perfectly. So there's one more thing I need to teach you. So let's say we have a circle. Now this is the midpoint. And so we've got the radius. We have another radius. Now we've got this other stuff here. And then we've got this. Now if you look closely, you will discover that this part is a sector. Now instead of giving us the angle theta here, we're giving this angle here. Maybe let's call this gamma. Now how do we calculate the area of this sector here, since we do not know theta? Now if you've done circle geometry, you would understand that this is a connection to circle geometry. And it's a law in circle geometry. And this is the law. The law states that the angle at the center is twice the angle at the circumference. Now, to be frank and honest, sometimes this can be confusing. Now, the way I usually remember this law, and just to make sure I do not confuse it, is that if I've got a circle in my mind, and then we've got a diameter, now I know that this is a semicircle. And then I know this law definitely, that in a semicircle, the angle at the circumference is 90 degrees. So I've got this place as 90 degrees. And the reason for that is that this part here is 180. Angle on a line is 180 degrees. And in fact, angle in a semicircle is 180 degrees. So it's like this 180, this 90. So this part, angle at the center, is twice this part, angle at the circumference. Does that make sense? Alright, let's take an example. So we are told to calculate the area of the sector AOC. Now remember, O is the center of the circle. Now let's try to solve this. Now remember that area of a sector equals to theta over 360 times pi r square. Now this is the sector we are referring to, sector AOC. Now, but we do not know theta. We don't know this angle here, which is theta. So how do we find theta? We write, recall that angle at the center equals to 2 times angle at the circumference. So this implies that theta equals to 2 times 45, which is equals to 90 degrees. Do you understand this? Now, so we can find the area of the sector now, since we know theta already. Now let's do this. So we have area equals to, theta is what? 90 over 360 times pi is 22 over 7 times radius is 7, so we have 7 square. Do you understand this? 0 cancels 0. 9 here 1, 9 in 36 is 4, 2 here 2, 2 in 22 is 11. So we are left with area equals to 1 over 2 times 11 over 7 times 7 squared 7 times 7. So 7 here 1, 7 here 1. So we are left with area equals to 11 times 7 all over 2. So area equals to 11 times 7 is 77 all over 2, which means that area equals to 2 in 7 is 3, remainder 1. 2 in 17 is 8, remainder 1. Point, add 0. 2 in 10 is 5. So we have 38.5 centimeters square. And here's the answer to the area of the sector AOC. Now don't forget that angle at the center is usually twice the angle at the circumference. Now remember, I told you the picture that comes to my mind is this. Now we've got this semicircle. This place is 180 and here's 90. So I know in my mind that angle at the center is twice the angle at the circumference. I hope you understand.